Welcome back to the Gut Check series in partnership with ZOE. I'm Dr. William Li. I'm a physician, scientist, and author of the New York Times bestselling book, Eat to Beat Disease. And today I am honored and pleased to be joined by Dr. Sarah Berry, who is a member of the ZOE Scientific Advisory Board, as well as an associate professor, also known as Reader, at the Department of Nutritional Sciences at King's College in London. Dr. Berry is also the lead nutritional scientist on ZOE's PREDICT studies, and she has a lot of experience with cardiometabolic clinical trials. So the PREDICT study is one of the largest nutrition studies in the world. Please welcome Sarah.
Thank you very much for having me today.
Yeah, Sarah, it is so great to see you, and I appreciate you participating in this series. Can you start by sharing, how did you get to be passionate about nutrition sciences? What is your origin story?
So I originally studied physiology at university, but I'm so passionate about the kind of rapidly evolving side of nutritional research. And now that we know it plays such a huge role in so many aspects of good health as well as ill health. And so its breadth and its real life application alongside the rapid pace of knowledge growth, I think makes it such an exciting field to be part of. And what excites me even more is being part of these ZOE PREDICT studies that you mentioned, which are really at the forefront of precision nutrition and pushing the boundaries on nutritional research. And I often think of them as allowing us to push the fast forward button on nutrition discoveries, which for me brings even added passion to my involvement in nutritional research.
That's very exciting. I think you and I share, from a science perspective, the idea that we all appreciate the body of knowledge that came before us. That's really what we spent our education studying. But then the opportunity to be able to push that fast forward button to look at what the future is going to bring to us is extremely exciting to me across multiple areas. And I think that when it comes to gut health, nutrition studies, and health itself, the future is exciting indeed. Can you tell us a little bit more about what the ZOE project is all about, and how does it connect to personalizing your nutrition status, and I think it has to do with the microbiome.
Yeah, absolutely. So the ZOE PREDICT program is the world's largest personalized nutrition program, and it's a whole series of studies to unravel how we respond to food, what determines our responses to food. And it's capitalizing on some really exciting times again in nutritional science, with the evolution of citizen science, with our ability to capture large scale data from all of these hundreds of thousands of people that want to be part of this evolution of nutritional research. And we're also using latest technologies for remote testing, allowing us to collect really high precision data, so that for the first time in the ZOE PREDICT program, we can look across a whole wide breadth of health parameters, which is really important in precision nutrition. It's really important that we don't look at single determinants, or what we call exposures, and single outcomes. We know that how we respond to food is determined by lots of different factors. And so what we can do by collecting a wide breadth and depth and scale of data is actually look across a whole many interrelated factors that determine how we respond to food. And I think it's important to mention kind of why we started out on this journey as well, and why we're so interested in precision nutrition. So we're really starting to recognize how complex we are as individuals, and how complex food is, and therefore how variable different people's responses to food are, and how this whole one size fits all approach that we've typically taken in terms of the advice that we give about food and looking at average responses in nutritional research really isn't the best approach. And so a way to kind of explain this, I think, to viewers is, imagine the thousands of biological pathways that we all have that differ for each and every individual one of us, that are involved in processing the thousands of different chemicals that are in foods. And then, throw these together and you see that actually how we respond to food is really complex, and that each and every one of us will respond slightly differently to the same food. Now, as I said, population guidelines take this one-size-fits-all approach, but within these broad healthy eating patterns and guidelines, there's huge scope for us to personalize dietary recommendations based on our unique biology. And I think that we're at this really kind of exciting transition in nutritional science, using these novel technologies that I mentioned, citizen science. So for the first time ever, we can explore within our ZOE Predict studies how much variability there is between us, or what's determining this variability. And we can start to piece together the many, many pieces of the very intricate puzzle, which is us and how we respond to food.
So that's very exciting. What does, I am a big fan of the idea of citizen science. Yeah. Another way of actually thinking about it is the real world, whereas in clinical trials that you might see in a drug company, for example, pharmaceutical company, you really try to recruit and control and limit the population you're studying. And so in fact, you do get more, let's say, narrow, you're able to ask narrow questions within a narrow population, and you tend to get sort of a yes or no answer. What I love about the idea of real world is that it's what is actually happening in all of us in real life. And we're not excluding things, we're embracing and including pretty much everybody coming in. And the fact that ZOE Predict is actually wading into that with eyes wide open to be able to gather that information is exciting indeed. Can you tell us who can participate and what technologies do they need in order to be able to participate in this?
Yeah, I mean, I think if I can just take a step back to one of the points that you made there is a real asset with the work that we're doing is the fact that we are looking in that real life setting at how people respond to food. You know, I've spent the last 25 years running very tightly controlled randomized clinical trials in my metabolic research unit. And what we actually need to look at is the differences between individuals, but we really need to look at also the differences that we get day to day within an individual. So we often refer to the term inter-individual variability, which is the difference between, for example, my response and your response. But there's another term that's really important, which is intra-individual variability, which is how do I respond day to day? And this is really key because we know that it's not just us and our own unique biology that's important, but we know that there's many extrinsic factors, and we can touch on these a little bit later, but we know that how we eat is really important. Time of day, meal sequence, sleep, stress, exercise, which is key. And so to move on to what you asked about the novel technologies and how and what we're actually measuring, we're trying to capture all of this. We're trying to capture information on people's biology. So we are still doing quite traditional measures, so blood sampling, body composition measures, blood pressure, for example. But we're also capturing a lot of data around meal context. And by this, I mean how we're eating. So things that I just mentioned, like sleep, exercise, timing of day and meal sequencing. We're also capturing data on the microbiome, which we can come back and discuss in more detail, although I know you've explored this with Will as well. And we're capturing data on genetics as well. And so we're using a lot of remote technology. So across the Predict studies, we've had Predict 1 and Predict 2, which was quite intensive and involved some clinic tests and some and an at-home phase. But with our Predict 3 study, which is a huge study that's ongoing at the moment, it's an exclusively remote study. And I think it's a real paradigm shift in how we think about conducting nutritional research and how we think about also capturing information about people and about how they respond to food. So we're using wearable technologies such as continuous glucose monitors. We're using activity monitors to monitor activity, exercise, sleep. We're using an app, which we developed specifically for this purpose to monitor what people are eating. And dietary assessment is often, I think, viewed as kind of the poor man's part of nutritional research, the boring part of nutritional research. But if we're not properly capturing what people are eating, how on earth can we be able to unravel how that food is determining their responses.
How does that work? How do you capture, how does an app capture what people are eating?
Good question. So this was specifically designed for the ZOE Predict studies and also the ZOE product. It's a core part of this. And it integrates many different ways of assessing dietary intake. So we use the very traditional weighed food logging that we've used for many years in nutritional research, but we're also using barcoding and pictures as well. And what we have is a team of nutritional scientists that for the Predict studies have in real time been monitoring what is actually put into the app by our participants, and they can ensure that the best quality dietary assessment data is being logged, which means we can have real confidence in what we're measuring in terms of what people are eating, which is really important, particularly when we're using this as a core foundation for the machine learning and AI that we're building from this.
So this is truly having the person participating, so-called subject, really being the citizen scientist. They just go on about their lives, but they're wearing or carrying the technology or putting some easy inputs in that allow the rocket scientists behind the scenes to be able to crunch the information into more meaningful ways. That is super cool. I want to hear a little bit about the microbiome. How does the microbiome play a role in Predict? What do people need to do? How do they just send samples in? How does that work?
So participants get sent a kit, which includes the different wearables like the continuous glucose monitors, a pot for their stool sample, and over a 2-week period, we monitor a whole host of different things, and people record their information on the app. And at the end of the 2 weeks, they send everything back to us, including their stool sample, their continuous glucose monitor, and other devices that they have. What we then do is we piece together all these different bits of the puzzle to look for each individual. What are the key factors determining a given response to food? And what we've seen is that there's massive variability between individuals' responses to food. So we're seeing about a 20-fold difference, for example, between how I might respond to exactly the same food compared to how you might respond to exactly the same food. What we're now doing is we're teasing apart what's causing this variability, what causes this 20-fold difference between how I respond and you respond. And what's been really exciting with our Predict 1 study is we predominantly recruited twins. So we recruited from the Twins UK cohort. So we could actually start to discriminate what's due to genetics, what's predetermined by our genes, and what's modifiable. And I think this is a really exciting part of the research, that we found that actually genetics only played a small role. And I was a child growing up in the 70s at this time of the explosion of genetic discoveries, where I was told, oh, well, it's all predetermined by your genes. And I think it's really empowering to viewers that actually we found very little is predetermined by our genes. The majority of how we respond to food is from modifiable factors, such as our microbiome, which is a huge piece of the puzzle, such as what I mentioned, some of these other factors, how we eat, our body weight as well.
So you're saying a set of twins that have the same genetics, when you actually take a look at feeding them the same thing or they're eating the same thing, you're discovering that twin 1 and twin 2 have different responses to the food. And you're actually discovering that the microbiome actually plays a role in that. And genetics, even though they should be very similar, plays less of a role. Is there a number that you can throw out there, like out of 100%, what percent genetics would play a role? Is it less than 20%? Is it how much does the microbiome play a role? This is an area of running research. And so I know that I don't want to put you on a spot with numerics, but really just sort of just for an idea for people listening, how important is the genetics and how important is a factor like microbiome?
Yeah, so it's actually dependent on the outcome. And by outcome, I mean the health outcome that we're interested in. So we've been measuring a whole array of different health outcomes. So we've been looking at the health of the microbiome. We've been looking at blood sugar responses. So you will be familiar with the term postprandial glycemia, which is this rapid increase in circulating blood sugar after consuming a carbohydrate-rich meal. We've also been looking at blood fat responses, which we term postprandial lipemia, which is this more slow rise in circulating blood fat after consuming fat in a meal. We've been looking at inflammatory responses. So we've been looking at circulating inflammatory markers, again, in the short-term period after consuming a meal. The contribution that genetics makes depends on which of those we're interested in. So to give you a few numbers, because you've asked me, for circulating blood fat, so this postprandial lipemia that I mentioned, we see that it contributes to less than about 5% of the circulating blood fat. For blood sugar, we see that it's nearer about 40 to 50%. When we factor in the microbiome, this is something that we're still exploring more and more, but we see, interestingly, that the microbiome actually has quite a large proportion in terms of how it contributes to the blood fat response, and still contributes a good amount to the blood sugar response as well.
That is so amazing that studies like PREDICT are able to address some of these fundamental questions. Working with ZOE and working with PREDICT and with your background, you must have, every time you explore one area, like any good area of science, I'm sure it raises more questions. Where are some of the future areas that you see this going, and can you share with us some of the future directions?
Yeah, so we're sitting on a gold mine of data with the PREDICT program, and I'm so blessed to be involved with it because it's so exciting. I stay up very late into the night crunching the numbers because I'm so excited by all of the different questions that are thrown up. And what's really exciting is that we have an amazing team of data scientists that are able to, in real time, answer some questions. And so we can move on from there very quickly in this rapidly evolving expansion of our knowledge. Projects that we're currently working on are around menopause. So we're really delving deep into looking at how menopausal status impacts our responses to food, because we see a big difference in risk of chronic diseases, particularly cardiovascular disease, between pre and postmenopausal women. But it's a really understudied area of research. So we're doing quite a deep dive into this, and to give you a sneak preview of some of our results, we're seeing that postprandial responses, so this postprandial blood glucose and this postprandial blood fat response is very different, even in age-matched menopausal women. And what's also interesting is we're looking at what determines someone's blood fat or blood sugar response or blood inflammatory response postmenopausally versus premenopausally. And we see there's different determinants. So just to give you a kind of example, we see that sleep is really important in determining this food-induced inflammation postmenopausally, but that actually how much sleep you have isn't that important for premenopausal. And this allows us to give that really targeted, personalized advice, depending, for example, just on menopausal status. Other areas that we're looking into are sleep. And I know that there's going to be a kind of deeper dive on this, but the kind of things that we're finding is that sleep duration, sleep quality, but also the midpoint of sleep, which is that the midpoint between when you go to sleep and when you wake up is really important. And so we're seeing that actually, if you have a later midpoint, you're going to bed later, even if you have the same duration of sleep as someone else that has an earlier midpoint, your glycemic control, so your blood sugar levels the next day to the same standardized meal are worse. So again, showing us that just simple changes like changing the time that you're going to bed can actually have a big impact.
Wow, just hearing you talk about that raises ideas in my head. Some of them would be exposure to blue light from a mobile device, whether or not that has an impact on those metabolic functions tied to sleep, tied to how food is digested. And another one that actually I think would be very exciting to think about is temperature in which you are sleeping, your ambient temperature. We know that, high temperatures versus low temperatures clearly influence the quality of your sleep as well as the quality of your immune system. And since immunity is so closely tied to microbiome, which is then tied to diet, I'm certain you're not only accumulating a gold mine, but you're furthering the depth of the mine itself in the work that you're actually doing. Well, look, we've come to the end of this program, but I can't wait to see the research that the results that ZOE comes up with. And I can't stress enough the importance of the type of work that you're doing, which is science-backed, but really involves real world scenarios, and then using the tools, precise tools, to be able to query the data and then being able to do the type of analysis that essentially upends a lot of the ways that we've been studying groups of people in the past, where we would ask yes or no after a extraordinary long period of time, and research moves so much quicker now by being able to gather the information, ask those questions, and iterate and reiterate what's going on. This is something that I believe in. I built a lot of the research in my career around this. And so, Sarah, thank you so much for your time joining us, and also for the powerful work that you're actually doing in the nutritional science space.
Thank you for having me.
Thanks everyone for tuning in. See you soon.